Okay, so here's an example. Mount Bora is the tallest mountain in Idaho, and it's 12,662 feet tall. From the summit of Bora, what is the greatest distance you can see? And they consider that to be the distance from the top of Bora to the horizon. Answer to the nearest mile. Okay, their hint is that the Earth's radius is 4,000 miles and 5,280 feet are a mile. The first thing I'm going to want to do here is draw a picture of the situation that I have going on here. So let's take a look. I know I have a circle, okay, because that's my Earth. We're pretending Earth is an actual circle, okay. The distance from the Earth's radius, so the distance from the center of the Earth to the edge, is 4,000 miles. Then we have Mount Bora. Now Mount Bora, notice, is going to sit on the surface of the Earth here, and the height of Mount Bora is 12,626 feet. So I'm going to extend this line a little bit more, and that is my 12,662. Sorry, I said it wrong the first time. Feet. Now we want everything in the same dimensions, and it says to get the answer to the nearest mile. So I'm right now going to change these feet to miles. It said there were 5,280 feet in a mile. So let's take our 5,662 feet, divide by 5,280. And we find that it's about 2.4 miles, 2.398. Okay, so this distance is 2.4 miles. They want to know, how far can you see? Okay, how far is it to the horizon? So this would be our horizon, okay, as we gaze down from the mountain. And notice the point where we touch the surface of the Earth, that's our horizon. So they want to know this distance right here. I'm going to call it the distance D. Okay, so far we have a setup. We're going to use that property of tangents, that if you have a tangent line, that tangent line will be perpendicular to the radius wherever it touches the circle. So right here, if I draw a radius to this point right here, I know I will have a right angle, and you'll see why we're setting it up that way in just a second. So I'm going to take my draw another radius. I want to draw it to the point of tangency, the point where that line touches the circle. It makes a right angle, which notice means that I have a right triangle here. I have 1, 2, 3 sides, and here's my right angle. All right, so what we're going to be using here is the Pythagorean theorem. The other thing I can fill in is, since this is the radius also, I know it's also 4,000 miles. Okay, so this is the picture that we have. I'm going to just kind of pull this over here so that I just have to worry about right triangles now that I have my property that I know I'm using. Okay, so I'm just going to pull this right triangle over so that we can clean it up a little bit so that we can do our calculations. Okay, so we don't know the length of this side. That was our distance. We know the base here is 4,000. What about our hypotenuse? Well, it was 4,000 plus 2.4 more. So it's 4,002.4. Okay, let's use the Pythagorean theorem. Which, remember, it says that a squared plus b squared equals c squared. Very specifically, a and b are the legs, so our legs for our triangle are the d and the 4,000. C is always your hypotenuse, so that's always your longest side over here. That's that hypotenuse that's across from the right angle. So now let's fill in our information here. a squared, that's my d. I don't know its measure, so I'm just going to call it d squared, plus the other leg, 4,000 squared, equals the hypotenuse squared, so 4,002.4 squared. We do our squaring, and do not forget that squared means to take a number times itself. So 4,000 squared is 4,000 times 4,000. So I'm going to have to expand this a little bit because that's a really big number. Okay. So we get 16 million. D squared plus 16 million. Now let's square the 4,002.4. So that means, again, to take it times itself. And we get just slightly bigger than that. We get 16,019,205.76. From here, we're still solving for our D. Okay, so we need to get rid of this 16 million from this side. To do that, I'm going to subtract 16 million. Okay, that leaves me with just d squared on the left side equals 19,205.76. Now I'm not done yet because to solve for d I have to get rid of that squared. Remember, anytime you have a squared, to remove it you do the opposite of squaring, which is to take the square root. So I take the square root of 19,205 and that will give me my answer. So I get the distance is 138.584. They wanted it rounded to the nearest mile, so that would be 139. The 5 makes it round up to 139. Okay, so we did use our properties of tangents to solve this. We drew a picture of what was happening. That gave us a right triangle, and then we used the right triangle with the Pythagorean theorem to go ahead and solve.